So, good afternoon, everyone. I know you had a quite short break, and I'm glad you made it. So just come in, actually have a seat, and then we'll start with the presentation. So what I'm going to talk about is about, we're going to see, how I can optimize my Spring Boot applications. You have seen today already many things, right? And even yesterday in the keynote, talks about, from Sebastian Deleuze, for example, showing Java 21, virtual threads, and so on and so forth. I'm going to show you the examples with some data I did some benchmarking with. And actually, just that you're aware of, I show you some numbers and they are for education purposes only. So, you need to benchmark your own application and find out what fits you best. But I'm going to show you some things which gives you an indication in which direction it can go when you try to optimize things. I will actually also show it from different perspectives. So bear with me, wait a bit, and you will see then afterwards the few sections we do. But first, a little things about me. So it's Patrick, I'm from Zurich. I am also a consultant. I work with software teams creating real solutions for humans. I think that's very important. I do architecture. I do a lot of Spring since it feels like almost forever, since 2007-ish. And I still help teams to use Spring in their environment and do a lot of other things. And besides that, I also like to teach, so at the University of Applied Sciences, and I'm very much involved also in the software development community, for example, the Java user group and other things as well. So you get some background or some idea who I am, but the thing is actually parts of this actually also from my current work I do. So what is actually the problem? Why do I do this talk and so on? So the thing is actually if you're going to the cloud and if you're trying to migrate to the cloud, things change slightly because your resources you're consuming with the app, they change. You don't have that beefy machines anymore as you had in the past, right? So that's why I want to show you things, and not in a Hello World example. And if Josh is around, sorry for that, Josh, but you're just showing Hello World examples. They look nice, but I can show you how your application starts up in half of the time, uses about 30% less memory, and also even has more throughput. And I can actually show this with some real data. So I'm a Java guy. I love Spring Boot, and that's why I'm going to show you all these things. So let's dive into the topic. And the question is actually when we dive into the topic, when somebody approaches you and says we are moving your application to the cloud, how much resources is your application going to use? We all have quite good machines, right? You say, yeah, the application starts on my machine in 5, 7, 10 seconds, maybe that. But in the cloud, things behave totally different, right? It's actually hard to guess. You might have even discussions with your infrastructure guys where they say, you get a fourth of a virtual CPU for your application, or maybe a tenth of that, right? So how would my application behave there? Maybe it's good enough when the application runs, but it's really bad for your startup times. And so actually to answer the questions, how much CPU your application uses, how much RAM actually is used, and so on and so forth, it's quite difficult to answer. So the thing is also on the other hand, which technology are you going to use when you move to the cloud? And we know actually Java is maybe not the perfect solution for serverless, right? But maybe it's the tool we know best. And we all know, to be honest, it's easier actually to change the technology and improve the technology than to change people, right? So why should we move every 2 years to another technology just because they seem to be better? So it's really easier actually to really change the technology and make them faster. And so that's basically what we see as well with the recent developments. You saw it also in previous presentations with native images, with app CDS and things like that, right? And then actually on the other hand, we also need to consider what kind of application we use or we write actually. If we have a long running process like a web application which stays there for a while, you need to have different things compared to if you do serverless. So these are lots of considerations you need to do when you actually like migrate your application. And yeah, I'm going to show you a few things like in which direction you could like improve your application. So we are going to have a look at first the application you have probably seen already today a few times. I'm talking about the pet clinic because it's the example you can actually also take afterwards and do some benchmarking on it. Then actually we take this as a baseline. That means like we measure certain things we are going to compare against. And then afterwards we talk a little bit about JVM optimizations, Spring Boot optimizations, maybe also some application optimizations. Then also talking about other runtimes. And in the end, some conclusions and also like some combinations of all the things we have been talking about previously. So I hope everyone has a pen with you, so actually you can write down the things and try it out tomorrow at work. So you may know the Spring Pet Clinic. That's this nice, cute thing which is always shown actually like on stage. It's very simple, so that's why I'm not going to browse through. I just have like a few slides. But then actually like what is there, and I would love to mention as well, there is not only the regular pet clinic, there is also a Spring Pet Clinic community. So if you're interested in different technologies, for example, like you want to try things like with Angular or React or HTMX or Vaadin, for example, there are like implementations of the pet clinic with this same UI, basically, like in different technologies. And for me, that's usually a very good starting point to see like this technology in action, right? And the pet clinic community is not really an official Spring project. It's really maintained by the community. So yeah, have a look at this. I find it quite interesting. But besides that, I have to tell you, no, we are not going to have a look at a project from the pet clinic community. We are looking at the regular pet clinic. So therefore, actually, like, we will use the application which is based on Spring Boot. They have some caching built in, which is based on caffeine. So that is very nice for like one single application. So if you don't run it like multiple times, then you have like server-side rendering. You have Spring Data JPA. You use like a database. The Pet Clinic supports MySQL, Postgres, and H2. For my purpose, I go just like with H2 because I thought, well, I mean, if you benchmark your application, it doesn't matter. And for my testing, it's simpler actually to set up the database, which is in memory than, for example, a real database. But it doesn't matter so much. We will still see like quite good effects in the application. And then obviously the power horse, Spring MVC, which is actually like the base for all web-based technologies in the Spring ecosystem. So this is kind of the stack we are going to use, right? So when we are going to talk about optimization, we need to be aware of our technology stack in general. So that means like when we are going to take a baseline, or I show you the number afterwards to this baseline, we will use the following technologies. So the whole setup is actually based on the OCI containers, so the Docker containers, but built with build packs. Just a short question. Who of you is using build packs in production? Just a few of them. The others are missing out something because build packs are awesome. I'm just going to tell you afterwards why. You really should use them. Then actually like the current pet clinic is still on Java 17. That's not bad because Java 17 is really perfect. We'll see that also later. Spring Boot 3.3, so recently upgraded. It has test containers in there which are used in the integration tests, and also the application will do some database migration basically during startup. We are going to have a look at things like build time of the application. We look at the startup time. We look at the resource usage, so basically like the RAM usage, because that's something you can easily like get out of a container. Then actually we look at the image size and we look at the throughput of the application. So that's basically like what we are going to see. Now, just a few words because you didn't know build pack so well. That's like the thing which is already built in Spring Boot and you definitely should use. And I like it quite a lot. So the build packs are implemented with Paketo, And it's kind of a thing which helps you to containerize your application, and actually it doesn't matter what kind of technology you're using. You can do it with Java, you can do it with GraalVM, you can do it with PHP, you can do it with whatever you like, what you see on the slide. It helps you to containerize the thing. So it's basically a command line tool, but actually like the Spring Boot Maven plugin, for example, contains that already, and we just can leverage the things from Paketo with the Maven plugin in an easy way. So I think actually like that's a thing you should definitely use, because it really reduces the cognitive load of the developers, because you don't have to be the master of disaster in building Docker files the correct way. And we have seen that also in previous talks already, also today, so that actually like you don't even have to think of how to do the perfect Docker container. And what you usually find actually in blog posts is that the examples you see there often actually run with a privileged user, which is actually like not a good practice, and you should never do that. And the build packs do so many things right. Just to show you like what they do right is just a screenshot of the logs when you start up your application. And I know it's quite tiny, but the block above the Pet Clinic logo is actually like the output what the build pack actually additionally adds to your running application. So it's going to patch, for example, the CA certs. It, for example, calculates the parameters for your memory usage of the JVM. It adds parameters like the Spring Cloud bindings, which actually enables you like liveness and readiness probes automatically. You just don't have to think of this. And if you think of the parameters from the JVM memory calculator, when you would have to like constrain the resources on the application, so that means like you reduce the CPU, you reduce the memory, you would have to provide usually like parameters from the outside to the JVM to actually say you should run better because you have less memory available, for example. And the JVM memory calculator just calculates for you the parameters in a quite good way. And it's a thing which is there already for ages. So I have seen that already when Cloud Foundry was a thing. Some of you might remember. So it's quite stable and it's used for a long time actually. So, and these are things why I think actually like build packs are awesome, because I don't have to care about that. And the other thing is, if you have good eyes, you might see that the application is running with the CNB user and it's not the root user, which you would have, as I said before, like in a lot of examples you find online. So definitely like the thing you should actually use. And I say build packs or the Docker containers created with the build packs are 1,000 times better than your regular Docker files, because you're going to miss so many things. They're even more secure because they're maintained by the build pack community. And what I realized is actually like if there is like a vulnerability in the base image, it takes about 2 to 3 days and the things are fixed automatically. Because if Canonical, the company behind Ubuntu, is basically like releasing patches, they get immediately into the new run image of the build packs. So that's the thing actually you should go for, and that's quite nice. So when I started my journey with all these like measuring like different Java versions, different Spring Boot versions and so on, I came across a tool from Maciej, the guy who talked just before me. And he exported actually some data which is available in Spring Boot with a tool, and you see actually like the artifact there. And I like it a lot because you can see the things already. I mean, like startup times, like how Spring Beans are created. Without that, you're going to use a profiler. You're just going to add this as an additional dependency. And then you could see like the measurements within Spring Boot, which are taken anyway. And he's exporting it with this startup report. It's a quite nice thing. You can actually use the magnifier to do some drill down and see like how long it took like for creating an individual Spring Beans. And when you're like on the upper level, it's more like that you are on the root of the graph of the Spring Beans. On the other hand, at the lower section, it's actually even more impressive because I like this like approach even better. It's the flame graph where I can see like which section take how long inside the startup. And when I did that with the pet clinic, I realized actually like, ooh, there is a section which is a little bit bigger than I expected, and it was all the magic done by Hibernate or Spring Data and Hibernate together, because it takes quite a while to initialize those things. So it was a surprise, because I'm not a Hibernate user. We often just like write SQL by hand, because then we don't have the problems you would have when using Hibernate, right? But that's just another story. So, just that's something to have a look at and get more familiarity with the things. Now let's have a look at the benchmarks. I'm running actually like benchmarks on my machine at home, because like my notebook or even your notebook is probably not the best thing to do benchmarks, because thermal throttling will be a problem. And that means like if the CPU gets hot, actually like it reduces the things. So what I'm usually doing is because of Corona, I bought like a nice desktop computer. Yes, it has RGB in there, but I'm not a gamer. But still, it has water cooling. And that's actually awesome, because my CPU is always on 70 degrees Celsius, which is a perfect temperature for the CPU, and I can keep it actually constant throughout the whole benchmarking. So I use my machine for that, and that means like my benchmark suite currently runs about like 16 hours. So because I test many things, like with several rounds of things to make sure that I get the proper data and I don't only have outliers. So you're just aware of that when you see my numbers afterwards. I try to do that on a dedicated machine. I'm using also a tool called WRK to do the measurements. And as you can see, I'm using like 4 threads, 200 connections, 60 seconds measurement, and yeah, I try to actually do around 2,000 requests a second on the application, which is kind of for my setup actually like the sweet spot. So I have like full throughput, and you will see we are not going to reach the 2,000 requests a second. There is like warm-up involved, but there is also some measurement involved, of course, and I do it with a setup or like with constrained resources, which are a little bit beefier. So that means like I use like 4 virtual CPUs there and 1 gigabyte of RAM. But we have also learned like in the presentations from today and yesterday, and even what I said initially, we might not have that amount of CPUs in the application. And I will give you also a hint like where you probably will get some other numbers if you would have less CPU. But actually, like to measure startup, the 4 CPU is basically the sweet spot. So that's actually like the place where you start the application the fastest. You cannot parallelize a lot more. So if you have 5, 6 CPUs, it doesn't get much better. But in the 2 to 4 CPU range, it's basically linear, the whole thing, like when you start your Spring application. Anyhow, let's get in some data. And what you see is basically like my baseline. That means like I have like Java 17 there. I built the application. It takes a while. The image, the Docker image which is created is like 360 megabytes roughly. Then actually like we have some startup of the application which takes about like 4.3 seconds. We use initial RAM just after the startup, which is about like 300 megabytes. I can get a throughput on the application almost like 2,000 requests a second. After that, immediately after that, we are like on 480 megabytes RAM usage, and then you see actually the percentiles that you see like the response times of a request of my application. We use that as a baseline, and we will always compare against this. So it's Java 17 on a recent patch level. So you see that with 17.011, which is quite important. Now, obviously, you can do some upgrades, and that's always something you should do. And that means also like with Java 21, you would either change the Java version in the POM file, or you can change it via property on the pet clinic, and then actually it will even create a container which contains Java 21 in there. And you see Java 21 is heavier than actually like the Java 17. Also, like the startup time in my case, it's even worse. It's not really that bad, right? It's just like 200 milliseconds, but it's slightly worse. And then actually, like you see, like on the memory level, we are roughly the same. And then also, like with the other numbers, yes, the Java 21 gets a little bit better. To be honest, actually, with the numbers, I usually do like 7 to 10 runs, and then I just remove the outliers and I do an averaging on the data. So that means like if they're really close to each other, I cannot guarantee it's really better, but it gives you an indication like if it's on a similar level or not. But we can say here, Java 21 actually is not that bad, and what I realized throughout the benchmarking since a long time, the patch level here, like the 11, really matters. So it feels to me like that Oracle actually, or the people contributing to the OpenJDK, they try to get out the release and they do the performance optimization later. So it really matters, like even like from 10 to 11, there was already, again, a performance boost, which is quite surprising to me. You would expect also, like if you go with Java 21, that things like might be slightly different, and that's like what you see here in the numbers, right? So even here, the build times, so I usually build even with the same Java version, which is afterwards like used inside. The build times go up. We have the image size also higher than compared to Java 17. We have like roughly the same amount of RAM used, and also like Java 22 actually got even better with the throughput. Like the latency of the request. So the thing is actually like what you should take with you, go with every patch level, with every minor version, because that's very important. It gets better over time and it's really worth it. Okay, so let's talk about some Java optimizations you could do, and there are also some ideas. I mean, I'm not going to dive deep into some parameters you can set on the JVM, but it's more like that you can do something like no verify, because there are sometimes some tricks where you can like really speed up your startup of your application. No verify is maybe not a thing I would do actually in production, but as you can see, it actually like in the startup time, it really matters. And the only thing what I do is I just provide as an environment variable the Java tool options and say no verify, and then it starts up already faster, and then also even the timings get better because the classes which are loaded are not verified. As I said, you should not do that in production, but just saying maybe it's good actually during development, maybe it's good enough for you. Another idea is actually like tackling the JIT. So you could actually use this tiered stop at level 1, where you basically define that you're going to use C1 and not the C2 JIT compiler. This is actually something you would probably see when you start your Spring Boot application within IntelliJ, because they do that to make the startup faster, because you don't really have load during development. There it makes really sense to like really start your application faster, right? And that's actually like also what you see here. The startup, just like by adding this parameter, will be way better. And that's something you might want to do. And if you go, for example, for serverless, where you just do like one request, maybe it's the perfect way to do that when you're using Java. But you see it's at the expense of the latency. And I'm not really joking, it's really like 15 seconds there. It's not like a typo or something. The whole optimization does not kick in. So it's really like you start up the application, there is no optimization going on afterwards from the JIT if you're on C1. And that's basically also the purpose of this JIT compiler. Okay, so if you want to dive deeper in things, I came across a tool which is quite nice. It's called the VM Options Explorer by Chris, whocodes.com. So if you deal with different distributions of Java, you can really like look all the parameters up. And it's all on a page with the recent version, so that's quite a nice thing when you want to check, like why do Bellsoft or Azul have different parameters? Why do they exist like on one side and not on the other? So you can have a look like what works for you. So it's quite a cool page, so you should also like then take a look at this. So let's talk about Spring Boot optimizations. So like one thing which is maybe like an easy thing could be lazy Spring Beans. So like turning all the Spring Beans lazy, and when they're used actually like you initialize them, that could be a thing to make your startup faster. And you see here, I'm basically like gaining 1 second startup just by saying actually like all the Spring Beans are initially or lazy initialized, but at the expense of afterwards, right? So the thing is actually like the first request will be very expensive. You don't see that in the numbers because I have a warm-up phase to actually do the throughput afterwards. So it does not reflect the numbers, but it's really like starting up faster. What I do as well is I turn off or turn on the lazy initialization also for Spring Data. So I can even like make even more lazy, right? That could be a thing you could do as well just to save some time without all the fancy stuff. But you have to be aware of there are some pros and cons there. That means like if the Spring Beans are lazy, your first request is expensive. If that one fails, actually your application is not going to fail. So that means you need to make sure that your configuration is fine, basically. Great. So what you also could do is you're like specifying the place where the application property is looked up. So Spring Boot has basically a strategy where it checks like from which directory, from outside of the jar file basically, or from inside the class path. And there are like several places where Spring Boot does the lookup. It's like 4 places, and then you have also the profile-specific YAML files or property files which are loaded as well. And if you can tell your Spring Boot application there is only like one file and that one is relevant, it's a little bit faster, or at least like what I would expect. So you don't see that much in the numbers because like they're all in the same range basically. You will gain just like a tiny little bit. It's basically just like file lookup you are going to miss when you are going to make it explicit, right? But in the end, if you have like a lot of small things, you might gain also some things as well, right? So that's why it's on the slide deck as well. Another thing actually like which is maybe a little bit, provocative I would say, is like don't use Spring Boot actuators. But only if you can afford to, right? So Spring Boot actuator come with a price, and I find it quite interesting to see, like, have a look at the numbers with the Spring Beans, actually. Like, with the actuators, we have like 452 Spring Beans. Without the actuators, it's like 276. So that means, like, we would gain there time that all these Spring Beans are not created, right? And that's why I kind of joke here, when you can afford not to use them, don't use it. But obviously we need it for many cases, and obviously also we would expect that actually like the measurements, the observability features and so on, it will take additional time actually to do this. So that's additional overhead in the end, right? So why not? I mean, we can do that if not needed. In the end, actually, the Spring Boot Pet Clinic doesn't need the actuators. We can safely remove that for our case, for example. And also, I've seen, like, in a customer project where the developers just said, we have a health endpoint and it returns Pong, right? I mean, if it serves your case, why not? Another thing actually, like, which was already also like a topic here, it's actually the ahead of time processing. And you know Spring Boot does component scanning, we use profiles and all the things which are like dynamically evaluated during runtime. And if you use Spring AOT, you're actually baking that into code. And you should have a look at the target folder because you will see actually like the code which is generated with the low-level API which registers the Spring Beans. So that means like profiles are evaluated, conditionals are evaluated, and so on. And it's baked into Java code. When you run it, you don't have to do class path scanning anymore. And actually, like Spring AOT serves as a replacement for the Spring Context Indexer, if you might know that. So there was a feature in the past where all the Spring Beans and entities you component scanned was in a file, and that file was read during the startup, so you didn't do component scanning at all. So it serves as a replacement, and Spring Context Indexer is not there anymore since Spring Boot 3.2. So I think it's actually quite a good replacement. What you're going to do in your application is you have to enable, when you use Maven, this process AOT as a special step, so that this like generation actually happens. And then for your build packs, if you're using build packs, you're going to specify this BP Spring AOT enabled because it will automatically enable the property for you. So there is a property where you can tell to use AOT or not. And by adding this environment variable to the build packs, actually like it will automatically add this property to your Docker container when you start your Spring Pet Clinic up, right? And you don't even have to think of this. Previously, that means like 4 weeks ago or so, you had to do it manually, and also like the AOT part was not baked into the build packs, but about like 3 weeks ago, they released actually like new build packs with the capability of AOT, which is quite nice, and I don't have to do anything. It's basically just like this additional goal and then actually like this variable for my build pack, and that's it, right? Which is actually quite nice. So the build pack actually creates additional files, so that's why actually the container images gets heavier, so there are more classes. And I wouldn't say it's a megabyte here. It's more like, yeah, a tiny bit more, and then actually like rounding up, and then it's 1 megabyte more. But what you also can see with the startup time, it improves already because there is no class path scanning necessary anymore, right? And after that, it should actually like behave like a regular Spring Boot application. I would say also like if the numbers are slightly different, that's just because I didn't measure like 100,000 times and to have like a perfect matching number, but I would expect like the thing gets like same. So that's a thing you should definitely turn on because it makes your startup faster. But obviously also the build time takes a little bit longer. You might have seen also that when you use IntelliJ that JMX is enabled in your Spring Boot app. Just saying, that actually slows down your Spring Boot app as well, but, and that's actually great, Spring Boot by default has no JMX enabled. Just because you might see in IntelliJ that actually like JMX is enabled, no, it doesn't matter in production, it's not turned on. And also the build packs actually don't expose like the features of JMX. So I would say I love build packs because like they always take care of the things and they do the right things at the right time, right? And that means also, for example, that the application when you build it, it also gets like deployed in an exploded format, for example. I don't have to care about that, it's done automatically. So that's why build packs are great, right? So let's talk about some application optimizations. And I mean, we could talk about many things, about caching, about your flyway scripts actually like manipulating the application when you run, or the database when you run the application, or like the things when you connect to other services which might slow down the startup. I'm not going to talk about that here. So it's more like something I came across is like that a lot of developers, they love to use starters because everyone uses starters. And when I do Spring trainings, I usually tell my students, starters are here to start, but not to finish, right? Not to end with. Because they're opinionated and you will pull in dependencies, maybe even dependencies you don't need. So, but how do you find out which dependencies you really need? And that's like why I have this slide in here, because I'm going to show you a very nice project which is actually called the depclean Maven plugin. And depclean is a project from a Swedish university where they basically like analyzes the bytecode, even like things for reflection, and they give you afterwards a report with that. So the report, and I had to shrink it a bit because the Pet Clinic uses quite a bit of dependencies. It shows you actually like the direct use dependencies, the transitive dependencies, the potentially unused dependencies, and so on. And you can decide yourself what you're going to remove. So the tool is quite nice actually. It's not just a dependency tree where you can see like what you use inside the application or what Maven provides to the class path. It's more like actually like it really analyzes what is used where. Obviously, you can imagine there are some challenges. The tool is not aware of XML files. It's not aware of the auto configuration imports file and so on. And even like the magic which is going on within Hibernate, it has no clue about that. So like the dynamic loading of like service provider interfaces and stuff like that. So yeah, so these kind of things are not really visible. And also in the report you would see like the web jars which are used in the Pet Clinic, they're also on the list to be removed because the references are in the HTML file, right? So I mean, obviously you have to take the report with a grain of salt, yes, and you just have to get a gut feeling actually what you can remove, and maybe you do some trial and error. In my case, with the pet clinic application, I went and removed, for example, because I don't need like REST endpoints, the pet clinic use server-side generated HTML, I removed all the checks and stuff. I removed like the DB drivers which weren't needed. I removed like the WebSocket implementation of Tomcat because it's not needed as well, and like other things. And there is even a bridge for SLF4J and Java util logging, which is also not needed at all. And I just could get rid of this, and you see that with the result, actually, like you can remove about 5 to 6 megabytes just in the pet clinic. I guess in your applications, it's maybe even more. So running actually the tool takes about 8 to 10 seconds in the pet clinic case. So you don't want to run it like all the time with your build. I just included the number so that you can see that, but maybe from time to time you can do that. And also you can even use it as a build breaker if you want to. So basically just like removing the dependencies makes the container more lightweight, and basically also you have like less stuff on the class path, so the application should be faster. Right. Then actually you might come across some other ideas where you say, yeah, there might be some other runtimes to use, because you might do some things like with the runtimes. And that's, for example, you could go and optimize with JLink the runtimes. And with JLink, basically you customize a runtime to your application. You just ship the modules you need actually like for your application. And that's why we have the module system in Java, right? So that we can like remove the things we don't need. You can do it on the command line, obviously, but you can also do it with the build packs, right? And with the build packs, you can go and remove things you don't need. And I included here numbers actually like from Java 17 and Java 21. And you can see actually like when you compare the Java 17 numbers, you can really drastically shrink the container image size. Yes, the numbers are right. The startups are slightly higher because there is also some compression on the JVM going on to get down with the numbers. But in the end, actually, yeah, the numbers for the latency and so on, they're like quite the same. But JLink is actually great because if you know things better, you can even instruct the modules you want to use. And that's like what I did here. And I just like even stripped out like the debug stuff and also like the man pages and the header files and other things you really don't need. And you see you just can get rid of another 2 megabytes or so, right? So yes, build packs are great, right? The other topic then next is actually AppCDS. So we heard that actually like that in the recent version of Spring Boot, AppCDS is a great thing. And you should use that. So that means like you don't have to load the classes from your jars, but you load them actually from a particular file. And you just can like specify that inside the build pack as well with another environment variable. So just like it will do everything for you, and that's quite awesome. So the everything means actually like it will do the training run, it will dump the archive from CDS, and then actually like when you start your Spring Boot app, it will actually load that archive as well in the startup, right? And that's actually quite nice. And you see here, there are some parameters which you would use actually when you do the steps manually. If you have like a multi-stage container build, then actually, yeah, you would have to do it yourself. But actually, the build pack does it for you. And the nice thing about the build pack is also, and you see that with the parameter, the Spring context exit on refresh. So that means the dump is actually made before the beans are created. So that means like when the classes are loaded, the dump is created. And then when you start your application, your Spring beans really get like initialized freshly. And that means also like credentials binding and other things. It behaves just like a regular Spring Boot application. So I think that's a very nice and additional approach, which you can really also then combine, for example, with the previous example we had, like with the AOT, right? And that's also something we heard already. Yeah. So did I tell you I love build packs? It makes life so much easier? Yes. Awesome. So when I talk about other runtimes, you can say, yeah, we might also use something like OpenJ9 for this. And OpenJ9 is really powerful because it's like memory efficient. I'm not saying it's faster startup and other things, but memory is definitely like the big thing in OpenJ9. And here you see like the different versions with Java 17 and 21 that like memory is really like reduced, and it's quite nice there. So what you have to do is you have to specify actually like an additional build pack, and we use the default Java build pack as well to inherit all the other optimizations, because all the other optimizations like the AOT, the app CDS and so on, they are like inside the Java build pack, and we are just going to override basically like the Liberica one. And so that means here OpenJ9 will be automatically used, and the container is built with this one. Great. Obviously, you can also use GraalVM, and I'm talking about GraalVM here as a JVM and not native images, because the GraalVM JIT is way better than Hotspot actually in optimizations. But they have a drawback here, because if you see like the image size, GraalVM as a JVM is quite heavy, right? So if you really need an optimized JIT, maybe that's a way to go. And you also just can change the build pack, as we have done in the previous example, just to the GraalVM one. Yes, I wrote on the top, it's like Community Edition. There is also the Oracle version, which is actually like the previous Enterprise Edition, which is actually way better. And if you don't build products, but if you run your application just like in the cloud, you should actually use this one here, because like the JIT is better, they have way more improvements which are not in the Community Edition. And the Community Edition of native images is used by other vendors as well, like Bellsoft, like Azul and so on. They only, and even Red Hat, they only can work with the Community Edition because there the code is like officially available. The Oracle version is like closed source. But it's better with the timings, as you can see. Great. Another thing I actually want to highlight, which I think is quite interesting, there are other builders out there. So build packs by default, they use a Ubuntu Chemi. And Ubuntu is maybe not like the thing your security guys like a lot. So yeah, I mean, it's maybe also not the best performant Linux distribution, but it's very handy and they have basically everything. But there are others out there. And for example, like a year ago, I learned about the Bellsoft builder. And Bellsoft actually has with their builder a Alpine Linux distribution underneath. So the run image uses Alpine, and it's quite small. And what they also do is they provide you the Alpaquita. They call it Alpaquita, so like the little one alpaca, which is a little bit cute. They use that one, actually, the Alpaquita Linux inside, and they also like give you this in different flavors with Muscle and glibc as an implementation. So they actually like implemented the muscle part, which is even more secure, where I would say like the glibc is actually a little bit more performant, but yeah, there are more hacks in there, and also like if you look at the container size or the image size, it's a little bit bigger, but the difference is not so huge. But as you can see now, the difference between the reference we have and actually the image size of muscle or the glibc one actually has changed drastically, right? So it's like way smaller. So I wrote there, it's only Java 17, because the developers at Bellsoft, they had lots of other things to do in the last year. So they didn't update the builder. That's actually a shame. And I'm always talking to them saying, hey, you should actually update it. I don't think it's a big deal. You just have to push new Docker containers to Docker Hub. That's basically it, right? Because like if you use their own base images with Alpaquita, they are very well maintained. So I had to go for Java 21, another route. And there I said, yeah, I need another tinier builder. And I'm using the default one, which is by default not meant for Java. But it still works, actually. So like you use the builder Chemi Tiny, which is like way slimmer. And you install just Java in there, and your Spring Boot application or your Pack Clinic just will work out of the box. And even like the Spring team uses the tiny image actually, like when they do their smoke test, they also use like the tiny builder. So it's actually fine, and we just get tinier, but actually we can support Java 21. Okay. So actually, like another thing then is obviously Graal native images, and we know they get better with startup, definitely. And I have here like both combined actually, like the Community Edition and the Oracle Edition. But what you know and what you also see from the numbers, if you have real load on the application, it's not the same like a JVM with a JIT. So you just have to be aware of GraalVM native images has its place, but maybe not on an application where you really need the JIT optimizations. Right. Great. Obviously, there is then the topic of CRaC, because it seems like I do a summary of everything which is in Java ecosystem, and I do. So CRaC would be an optimization possibility as well, and there are definitely some challenges with that. So you get from two vendors basically a JDK build with Java 17 and 21, where you can do snapshotting of your application and the restore is super fast, right? I mean, nowadays, you still have to do it manually with manual steps. And that's a little bit a shame because there is no build packs actually like which does that. But there are challenges which are not so easy to solve at the moment. And I think we have to wait until those challenges are done. So the problem is basically like your secrets, they are in the dump of the memory, which CRaC actually does. And that's an issue. And that means also like if you deploy your container image in test and in production, your credentials need to be the same, right? And that's like one of the issues we have there. So we would have like to like reload the application context to get the new credentials loaded. So there are too many challenges there. Definitely, but I mean, for certain cases, it's actually already good enough, and you might want to use it. But be aware of you do basically an environment-specific build. You will find actually on the website from Azul also like CRaC implementations for macOS and Windows. Pay attention; these are only developer editions, and it's simulated. So the real CRaC you only get on Linux, on real Linux. So that means you need to run it either in VirtualBox or like on a real Linux machine, actually. Everything else is just meant for development purposes and simulated. So I would say I cry because there is no CRaCs in build packs yet, but as I told you, it will take some time. Obviously, there is still like one topic missing, and that's actually the virtual threads. And the virtual threads is almost a no-brainer for our Spring Boot applications, and you should definitely add them. So if you run on Java 21, you need to specify a particular property where you say Spring Threads virtual enable true, so the virtual threads get enabled. And as you can see on my numbers, actually, the startup time actually takes a little bit longer until everything is initialized. That's quite surprising. I checked the numbers multiple times, so they're always the same. So the 4.9 seconds is like the thing where you make your trade-off, basically, right? But then in the end, the throughput actually, or even like the response times, they get better. Now, be aware of, like I did the benchmarking like with 4 cores, that's quite a beefy machine. If you would have less, the numbers would be actually like way better. So you get more benefits of virtual threads when you have like less CPUs. Okay, so let's summarize the things. We have seen a lot of topics here already, like how you can optimize your Spring Boot application. And there are like many ideas in there. Why could we not go and just combine some of them? So before we go there, be aware of that there are some conclusions I want to walk you through. Regarding the CPU, as I said, when you have like a fourth of a virtual CPU, your startup time might be still like very bad. Or you can like do some improvements there, but yeah, if you have like 2 to 4 cores, that's basically like the sweet spot. Regarding the throughput of your application, be aware of like that your application like is different than mine. So you have to do the benchmarks yourself and find the sweet spots there, what really like makes sense for you. And you also might have like different problems, right? You want to optimize in different areas. And that's why also maybe you should have also a look at different runtimes, because there is a reason why certain companies sell licenses for optimized JVMs, right? I mean, most of us might not use them, but there are reasons like why you can put your money on the table and get something others can't get. That's the thing. Okay, so there are other optimization ideas to my talk I came across with. So CRaC is still actually like missing that I can do a proper comparison. We could think of doing something like obfuscating the code, shrinking things, but that's quite hard with a Spring application when you do component scanning and stuff like that. Maybe I should try that again with AOT combined, and then you can obviously do even more JVM tuning and other things. And then also like Project Leiden, where they are still currently working on it, might be also a good thing actually like in the future, which helps us with the startup times of your application. Okay, so let's have a look at some examples where we just do some simple optimizations on the app. So in this case, actually like I'm going to remove some dependencies. I use a specific builder. I use JLink to shrink actually like the JVM down. I add some JVM parameters which are there anyway because the Java memory calculator is used like all the time. We are going to use application class data sharing. We use AOT. We might use like the lazy beans. Then also like specifying the location of the properties or the application YAML file. And then depending on Java 21 or Java 17, we might use virtual threads as well. And that's like what you're going to see on the slide, like everything combined except the virtual threads. So running on a very tiny run image, actually like with Alpaquita in there, you have like half of the startup time. You like reduce the memory consumption by a third, and actually like your numbers are really, really comparable, right? Then on the other hand, with Java 21, it's slightly different. So, but there we can actually have a beefier JDK, but the thing is actually like we can turn on virtual threads. And as you can see here, also like the optimization by the startup time is still like more than 1 second or almost like 1.5 seconds. And also like memory is also like still way better to the baseline. Okay, great. So that was my talk about like optimization possibilities which you can apply. So if I missed something, please let me know. I'm still here because I like to learn with you and maybe also get some other ideas. But I hope you get also, or you got also some inspiration actually like which you could apply in your application. And I'm sure, just like the 5 things or so we did like in the last examples, it takes you like a few minutes to do that, and your application is already way better than before. Thank you very much.